Bismillahirrahmanirrahim. We begin with the next chapter, which is on wireless LANs. We will look at what are the different characteristics of wireless LANs in terms of access control, in terms of the different types of networks, topologies that we have available, and how they work together with the MAC frame for IEEE 802.11. As we know, Wi-Fi has become one of the most predominant methods of communication today. Everyone uses Wi-Fi. Everyone uses it, and it is something that within the last 10 years has become very common. It's a very common thing. We hardly connect using the wired Ethernet LANs in our home. It's usually using Wi-Fi because it's convenient, right? Wireless connections, wireless technology gives you convenience. You can be anywhere and you can communicate. You don't need to be stuck to one location. You don't need to stick to one location. So in your house, you could move anywhere with your laptop or with your mobile, and you can still be connected to the internet. So it gives you freedom to move. It gives you freedom to access the internet from anywhere you want within the coverage. So this is why it has become a very a favorite mode of communication, you can say. Now let us compare wired LANs and wireless LANs. They have some key differences, some key characteristics. In terms of medium, right, you have wired LANs, you need wires to communicate. They can be different types of technologies. You have Ethernet. Even within Ethernet, you have 10 megabit per second, 100 megabit per second, 1 gigabit per second, different speeds of Ethernet LANs. And then you have other technologies. You have fiber optic, you have FDDI, right? Token ring. You have so many different types of wired communications. So any communication in a wired network takes place over wires. In wireless LANs, that is not the case. The medium is the air. So you have radio waves being transmitted over the air, and you have devices listening to the medium and receiving signals, and also they can send these signals in a similar manner. We are looking at these different characteristics now. Let's look at isolated LANs and what are the similarities when these concept is in wired networks, and how does it take place in wireless networks. In wired networks, you could bring 4 devices randomly, okay? Take a switch and connect these devices using the wire to this switch. And with this connection, these devices can communicate with one another. They can send and receive packets. They can do file transfers, etc. Okay. This is an isolated LAN. It is not connected to the network outside. It is not connected to the internet. You have formed an independent, isolated, separate, you could say, wired LAN where the hosts communicate with one another using through the switch. So this is for the wired network. In the wireless network, you have something called ad hoc network. Okay? You have the ad hoc network. In this case, hosts or wireless devices randomly come together, okay? And if they are within the range of one another, if they can hear one another, they can directly communicate with each other, okay? So they form a random network. So you could have two laptops, if you brought two laptops next to each other and you configured them ad hoc, to form an ad hoc network, you can send information among the two laptops. Similarly, you have other devices coming in, and when they connect to this ad hoc network, they can also share information. But if one device moves away, okay, if one device moves away, when it goes out of the range of these devices, when it goes a distance far away where it cannot hear these devices, it is no longer part of that ad hoc network because it has moved far away. And this is why the name is called ad hoc network. Any device can come in. If the other device wants to communicate, you establish a link and you communicate. But when the device goes out, the network is dissolved, does not exist anymore. In ad hoc networks, you have peer-to-peer communication, right? One device will communicate with the other device. Next, we have the infrastructure type of networks. In this case, we have the devices for a wired LAN, okay? For the wired LAN, we have the devices once again connected to a switch, and the switch is connected through a router to the internet. So all these devices using the router through the switch can communicate to the internet. They become connected. Now, in an wireless LAN, with the infrastructure type of wireless LAN, okay, all devices have access to an access point, a central controlling entity called the access point. Okay? So all these devices will communicate through the access point, and now this access point is a wired device, by the way. Okay? It has two interfaces, right? The access point, it would be something like this inside, okay? So you have the wired physical layer, okay, for this link, and then you have the wireless physical layer for the wireless side of things, and then you have the wired MAC and the wireless MAC. Okay, and then you have the physical layer, the IP layer sitting above it. So the access point is forming the interface between the wireless network and the wired side of the network. Devices inside an infrastructure network will communicate via the access point. Okay, they will all communicate to the access point. They can communicate with each other, mind you. Okay, they can communicate with one another, so they can form an ad hoc network and communicate. But in this case, if they want to communicate to the outside world, it will have to be done through the access point. And many times you also have devices communicating with one another, but through the access point. Okay, you can have that as well. So the access point is the central, you could say, like a controlling entity. Now, we have in wireless networks, we have CSMA, CA. Okay, we have a variation of CSMA, which is carrier sense multiple access with collision avoidance. In wired networks, if you remember, we had used CSMA CD, carrier sense multiple access with collision detection. But in this case, in wireless networks, we can't use CSMA CD. We have to use CSMA CA instead. Why is that? Remember, in CSMA CD, the device is doing full duplex, right? It's full duplex, which means a device is transmitting, but it is also sensing, right? It is sensing the medium. It is checking the medium, seeing, is it free? Is it busy? What's happening to the medium? But in wireless LANs, the devices don't have enough power to send and receive at the same time. They can either send or they will receive. Okay? So this is one of the reasons why you can't use CSMA CD. Collision detection. This is a very important feature in CSMA CD, right? And how did we say we detected collision? We said that if we had a normal signal on the wire, it meant the medium was busy. If there was nothing, the medium was empty. And if there was something of an abnormal intensity, signal intensity, it meant that there was a collision. Unfortunately, in CSMA, in wireless devices, we can't say for sure about this difference. Okay? Why? Because in wireless devices, first we have, let's say, a device here, okay, who is sending wirelessly. The signal is stronger near to the device, but as it goes away, okay, the intensity of the signal starts becoming weaker and weaker. So if you have a device somewhere here, close by, they can hear a strong signal. But if a device is somewhere far away, they will hear a weak signal. So in this case, even for a collision, if we said that this was the normal in wired networks, and if we say this is abnormal, it is possible that in the wireless scenario, a collision could be something like this. Okay? So in the wired scenario, you have a big difference, right, between a single signal and a collision signal. So you can easily find the difference. But in a wireless network, that's not the case. Because the device is far away, even the collision, it is a very small gap, not much difference from an original. Okay? Why is this? Because it is possible, as I said, if the device is far away, then even if there is a collision, okay, even if there is a collision happening, okay, then that collision, by the time it reaches the other end, it will not be that clear. So you can't say, is it really a collision or is it not a collision? So this is why in wireless networks, we can't have CSMA CD, because the second reason is the distance between the stations can be great. And we also have a third reason, being the hidden station problem, which we will cover in the coming slides. So we have looked at the problem with CSMA CD for wireless LANs. Why can't we use CSMA CD? Now, we have different types of groups, okay, architectures. We have something called the basic service set. Basic service set. You have two types of basic service sets. What is this? In a basic service set, you having devices coming together to form a group so they can communicate with one another. When the basic service set has an access point inside it, and as you know, this access point is connected to the wired network. And all these devices are communicating to the access point, which is connected to the infrastructure. So this type of a BSS is called infrastructure BSS, because you have the central entity access point connected to the infrastructure, and you have all devices communicating with the access point. In the ad hoc BSS, there is no access point. You have, as I mentioned earlier, devices will just come together if they are close enough to hear one another. That is fine. They will just form a network and they will start communicating. And then you have something called the extended BSS. Okay? Extended service set. ESS or extended BSS. What does this mean? Look at this case here. You have one BSS. You have devices inside this BSS, and they are communicating with the access point. You have another BSS, devices communicating with second access point. And you have a third BSS, devices connected to the access point. In here, okay, now all these access points are connected to a common network. Okay, they are connected to a common network. And this is called the distribution system, because you are distributing information from one BSS to another BSS. What is the advantage of this configuration, of this architecture? You could have a device in this BSS communicate with a device in this BSS via the access point, the distribution system, the switch or router, and to this access point to, and then to the destination. Okay, it is very much possible to have this type of communication. You could also have devices moving from one BSS to another BSS without losing connection. Why? Because the network is the same. Okay, the network is the same, and as you know, we did in class, when the network is the same, you can maintain the same IP address. So you could have your mobile moving from one access point to another access point and not lose connection. Okay, so this is the advantage of the extended service set. So you have every access point having its own set of managing its own set of mobile devices, and these access points in turn are connected via a common distribution system. Okay, extended service set. So we have different types of stations: no transition mobility, BSS transition mobility, and ESS transition mobility. What does this mean? What's the meaning of these different values, or these different concepts? So what did we say was the first one? No transition mobility. Okay? In this type, you have the BSS and the mobile is inside the BSS. Okay, the mobile is inside the BSS. You could have an access point, for example. Okay, but this mobile does not move outside, so it is no transition mobility. And then we said the next is BSS transition mobility. In BSS transition mobility, it means you could have a device moving from one BSS to another BSS. Okay? You could have a device moving from one BSS to another BSS. This is BSS transition mobility. Okay? Then we have ESS transition mobility. What does that mean? In ESS transition mobility, we have one ESS, okay, with access points and their own base stations, basic service sets, okay? So this is one ESS, and you could have another ESS in here, okay? You could have another ESS in here. And you're having the device moving from one ESS to another ESS. Got this? Okay, so you're changing the ESS now completely. In this case, there is no guarantee that the connection will be maintained, because it is possible that this is a different network with a different IP address range or different network address. So a mobile, when it moves here, it may have to change its IP address. It is very much possible. Okay? So these are the different types of mobility. No transition mobility, where the device is limited to the BSS, doesn't move outside the BSS. BSS transition mobility, where the device can move from one BSS to another BSS, right? And you have ESS transition mobility, where the device is moving from one extended service set to a different extended service set. So this was introduction for 802.11 wireless LAN. In the next group of slides, we will look at the functioning of CSMA CA.